Hello. This is my video submission for the Machine Learning Foundation for Product Managers course, Module 6, homework assignment. So, as we know, we already have the data for the combined cycle power plant. We have all the variables, which is temperature, ambient pressure, vacuum, humidity, uh, and we are predicting the net hourly electrical energy output. That is our target variable. So I already have the data for it. So initially, when it comes to model selection, there were two models which I considered. So when I went through the Wikipedia article for the combined cycle power plant, it was pretty evident that all of these variables have some kind of a relationship with the target variable. All of these four variables features have a relationship with this target variable, and the data is in a tabular format. So the two models which I was considering was one, regression with multiple variables, multiple features, and the other one was random forest. Now random forest is kind of a random forest is best again when we have tabular data, but it is most efficient as well. Like it is definitely better than the regression model. But let's say if we don't have values for some of the observations here, then random forest can still predict it. So saying that random forest is still better, I see we don't have any missing values in the tabular format data. So regression should work just fine for this. So that's why I have considered the regression model here over random. Random again, it's much better than regression, but regression should work fine when it comes to this tabular data. When I plot the scatter graph for these variables, I found that there is not a linear relationship with all the variables with the target variable. There is some kind of a non-linear relationship as well, but still, there was some kind of a correlation which I found between these variables and the target variable. So to do regression, what I initially did, uh, just making sure I have recording in progress. Yeah, I do have recording in progress. So what I did with this is basically I created another column here. If you see random, so this is just like random numbers. Basically, if you see the command random, the reason I did this because I want to divide my data set into training data and the test data. So as you can see here, 80% I've considered training data. So 80% of the total number of rows, which is 9568, comes to 7654. So 7654 is the number of rows I've kept for training, and the remaining number of rows I have kept for test data set. So if I go to training data set here, what I've done here is basically just did from the analysis toolkit, basically just ran a regression analysis, and this was my summary for regression analysis. Now if we scroll down here, the multiple IR, which is the correlation coefficient, is basically very close to 1. So that means there is some kind of the relationship between the variables, the features, and the target variable is very strong. So there is a positive linear relationship between features and the target. Now we also have the R square, which is 0.92. In this case, 9.23 of the variance is P is explained by the feature. So this is also very strong. The variance in the target variable is explained very well with the help of these features, which we already have. Adjusted R square, again, indicates a much better answer than the R square, which is all the features are basically contributing to the target variable, standard error, and observations. So yeah, I mean, overall, regression worked pretty fine for this particular for predicting the target variable here, as you can see from these values. So that's why this makes sense. I did not shift to any other model. This worked comparatively better for me. So as you can see here, I have the coefficients of all four variables, uh, and I also have the y-intercept here. So using this variables, the coefficients of all four variables and the intercept, I basically predicted PE here. So if you can see here, I have written down this formula, which is basically taking this value, multiplying it with the coefficient of each of these variables. So it follows basically y is equal to mx plus c if I have like one feature, but since it is multiple regression with multiple variables, it is y is equal to mx plus c, uh, with all the four features basically. So I also calculated RME and RMSE, which is comparatively very less here. So it indicates that only 3 points. So our target variable is just 3.65 deviation away from the actual original value. So which is fairly good, which is pretty good from a model standpoint. So yeah, overall, I mean, this is what I have, and the model predicted good values. Regression is, I think, it's a good algorithm, uh, good model for predicting the y or the target variable in this case. Thank you.